Hi, good evening. Welcome again to our Big Ideas campaign for the Cassini Hackathons. This evening, we're going to have Klaudia Bielinska from CloudFerro discussing with us what is Copernicus data and what is a DIAS platform and how will you be able to use the DIAS platform for the hackathon. So I hope you've had a good and inspiring Big Ideas campaign so far. We've had a launch event yesterday. Thank you all for attending as well. And also, our local organizers have given already info sessions, and there has been a business model workshop yesterday as well. So this evening, we're going to have a talk about the cloud platform, about CREODIAS, and how you'll be able to use it in the hackathon. So I have here with me Klaudia Bielinska, and Klaudia is going to tell you just in a bit about Copernicus data, and what it is, and what a DIAS platform is. And to give you already a little hint about it. So a DIAS platform is really a cloud platform operated here by CloudFerro that allows you to access Copernicus data and to work with this Earth observation data. It's petabytes of data that you'll be able to access for free. And in the hackathon, you'll be able to use the platform of CloudFerro for that. So Klaudia will also talk to you about how that's going to work for you in the hackathon. Please, if you have any questions, don't save them all for the end. You can just put them in the Q&A, and then in the last 15 minutes or so, we'll be having a Q&A with Klaudia about some of these topics. So if you have questions, put them in the Q&A, and for the rest, all I have to say, Klaudia, the floor is yours.
Thank you very much for this nice introduction. Thank you very much for the invitation. I'm really happy.
It's a pleasure.
Thank you. I'm really happy that today we can tell you more. I can tell you more about the CREODIAS platform, and I can tell you about Copernicus program, which is really useful and really needed for all of us. I hope that you will enjoy this time with me, and I'm really looking forward to your questions. I'll be happy to answer. And if not today, then just you can write me an email and ask me also questions through email. Okay, so I will show my presentation. So let's start and let's move to cloud. Okay, I hope you can see my presentation. So yes, at CloudFerro, I'm Earth Observation Product Manager. My, let's say, history with the CloudFerro started last year. So I've joined the team, and because I was first the customer, I was first using CREODIAS platform. So it was just, amazing opportunity to join the company, which has developed such a nice place to work with. So today's agenda for my presentation is first, I would like to just tell you very, very briefly who we are, who is CloudFerro, and what do we do. Then we will move to Copernicus, what is it about, then CREODIAS platform, in few words, how it looks like, what it's inside the platform, CREODIAS in practice. I will show you tools for data browsing, finding, and processing. Then at the end, maybe some just inspiring part, I will show you CREODIAS use cases, so the projects which has been developed on CREODIAS platform. And at the end, our Q&A session. So starting from beginning, CloudFerro, who we are and what do we do. So what is very important, we are a Polish company which has been established in 2015. So we have now 6 years. So what do? We provide cloud services. So storage, computing, processing, everything can be done in our clouds. That's our work. We mainly work for Earth observation and space sector, but we also try to work with different commercial companies, different organizations across the whole world, which can just make a good use of our cloud services. We've been really growing intensively. Today, I've counted actually that we have around 95 employees in our company. So most of us are IT guys working on the IT parts of our company. But here we have also Earth observation specialists, data scientists, and also administrative units, marketing department, and so on, as in every company. So we are a Polish company based in Warsaw, but we are not only working here on the Polish market. We are working across whole Europe and even across world. So people from different parts of the world are coming for our services. Who have been trusted by? So we've been working with many organization, companies, universities. So you can see here, for example, European Space Agency, German Space Agency, Polish Space Agencies, and also institutes, organizations which are working on research and development projects. You can see, for example, ECMWF, EUMETSAT, who are also working with us, and we are trying to give them the best of our cloud services. And our clouds, you can imagine that looking out the window, there are different clouds, but we are clouds made of metal. So our clouds are based in 7 different locations. Of course, Warsaw, we have here 3 locations, and Germany 4 locations, so it's Frankfurt and Darmstadt, and also 1 location in Reading, UK. So we provide clouds, like one open cloud environment, but also some of our customers, they wanted also to have their servers, for example, in their locations where the company is located. So we also provide that kind of services. Then you can see how our clouds look like. So there are long corridors with really highly developed best servers. And what is very important, that here, for example, in Warsaw, in the building where I'm now, downstairs there is our laboratory where my colleagues are building servers from the basics. So short introduction to CloudFerro, and then let's move to Copernicus. So maybe some of you know and some not what is Copernicus. Copernicus is European Union Earth Observation Program. So it was developed long time ago, and before the name Copernicus, it was called GMES. So it was Global Monitoring for Environment and Security. And the main idea of the Copernicus program is to deliver Earth observation data and also in situ data. So satellite imagery and also data which have been acquired, taken in field, let's say, measurements. So Copernicus is gathering different data sets, different data sets from different sources to provide everyone open and free access to the data. So you can make a good use of the data. You can download the data, search for the data, you can work on the data online for your projects. And also, I think that we all can benefit from this program, for Copernicus program. European Space Agency is announcing all the time different contests for the projects with the use of Copernicus data sets. And the Copernicus program is it's been all the time developed. So you will see the constellation of Sentinel satellites, which has been launched almost year by year. So we have different satellites looking on the Earth, and then we can benefit from the acquired data sets. And here, very nice information is that every day there is around 12 terabytes of data gathered within the Copernicus program. So it's actually tons of the data. Copernicus also delivers dedicated services. So we have here atmosphere, marine, land, climate change, security, and emergency. So we are calling it services, but those are actually data sets dedicated for different purposes. As an example, I can say, for example, when there are some floodings, when there are some earthquakes, and then different disasters are going around, then the Copernicus is focused on emergency services, security services, and then they are developing a lot of data sets within those services. You can also benefit from the services. You can take the data, you can download the data for free and work on the data sets for your purposes, for monitoring of your area and, for example, for specific projects. Okay, Sentinel mission. This is really important thing about the Copernicus program, because when the Copernicus program was launched, then different satellites were also been launched. So here at the moment, we have a constellation of Sentinel 1, 2, 3, 5, 6, and 4 moving around us. So the latest one, which was Sentinel-6, has been launched, and it's been operating since last year, and it's acquiring data from the oceans. Those Sentinel satellites has on board different sensors. Some of them have optical sensors, and some of them has radar sensors. So radar sensors, synthetic aperture radar. That means that those sensors can operate every day in the morning and at night, and no matter what the weather looks like. When we have the optical sensors, the situation is not it's not so let's say bright, because optical sensors need a source of light, so they don't operate at night. I mean, they operate, but they don't acquire good data at night. And when the clouds are on the sky, also you will have the clouds in your imagery. For example, if you will look for the data from different periods, you will have also different states of the data. So some will be covered by clouds, so some will be clear without clouds, and so on. So as you can see, data from those satellites are available within the Copernicus program, and I will show you how to access the data on CREODIAS platform. So here I wanted to show you example of some Sentinel data, acquired by Sentinel satellite. This is, for example, Sentinel-2 data set from the border of Canada and Greenland. Last year, CloudFerro company has launched a contest for the users of our platform to send us pictures of the most beautiful places on the earth. And those imagery were then published in the calendar. So probably this year we will launch the same contest. So we'll be happy if you can use our platform and then generate imagery. Maybe some additional information about Sentinel data. They have different resolutions. So the resolutions of the bands on Sentinel datasets are 10 meters, 20 meters, and 60 meters. And here you can see the resolution of 10 meters. So it's quite detailed resolution. Then another image of the Sentinel-2 as well. So this is the optical satellite. This is Aubari, Libya. You can see here also 10 meters resolution of the imagery. Then we can see here Italy and also Sentinel-2 imagery. And then you can see even here boats on the sea. Really nice detailed imagery. And here you can see Poland, Gdańsk, but this is different satellite. This is Sentinel-1, so radar satellite. So the imagery is not so colorful. It's mostly black, white, and gray. So you need to apply the different processing methods, different filtering methods to receive some parameters from those imagery. But this imagery, that kind of synthetic aperture radar imagery, is very useful for really wide, let's say, purposes. For example, you can monitor agriculture. You can monitor how the plants are growing on that kind of imagery. You can also monitor landslides on synthetic aperture radar monitoring, because it monitors movements which are happening on the Earth. So the monitoring from space of different things, of different processes ongoing. And this is just an example of the data set which was taken, which was acquired by the newest Sentinel-6 satellite. So this actually satellite, the purpose of the satellite is to measure the sea level. So you can see, for example, here how it differs. So some probably I would say that some oceans and seas they are rising, some are not. So you can so you can just monitor it and then see what are the changes of the sea level. So as you can see, we have data sets. We have also satellites. We have data sets from the in situ measurements. So some time ago, the European Commission thought about combining all of these data sets, let's say creating just one common place, which can be the access place to all of the data sets, and which will be very useful and, let's say, user-friendly place for the data users, for Copernicus datasets users. So that time they have opened the contest for Copernicus Data and Information Access Services, which is the short name DIAS, so DIAS. So that time, the contest, we took part, CloudFerro took part in this contest, and we have developed our platform, CREODIAS platform, and then also other consortiums around Europe developed their DIAS platforms. So we have CREODIAS platform, we have Mundi platform, we have Onda platform, we have Wikio platform, and also Sublu. So all of those platforms, they gave access to data sets, and they have also possibility to process the data sets in one place. So there is actually no need to download the data and to your computer and then to work with the data on your computer, but you can do everything in the cloud in one common place, which is really useful and really easy. So I would like to move to CREODIAS section and then tell you more about the platform and how to access and how to process the data in the cloud. So that's how this image shows how the platform works. So what is actually cloud computing? Cloud computing is a process to store the data, to access the data, to process the data in one place. So CloudFerro delivers cloud services. So we deliver private cloud, public cloud, and hybrid cloud. So CREODIAS platform is actually public cloud. So it's open for everyone. So everyone can make use of this platform. So I would say that this pandemic situation shows us that more and more of our users, of our customers, are going into cloud. It's much more easy. It's much more easier to work in the cloud, to work with your company, to share everything in the cloud. Now we are, for example, talking online, and it's been also much easier than years before. So the technology is really going up. So customers, users are going up into the clouds. where they can store the data and process the data, share the data in one place, which is very useful for them. How our platform works. As I showed you before, we have our servers in different locations. So actually, I can say that the cloud, which is actually the metal server. So the CREODIAS is actually metal server, I would say. It's an IT environment. We divide CREODIAS for the CREODIAS portal, which you can access just through the website. And then you can have access to our applications, our tools, which is EO Finder and EO Browser. And also we give our users access to cloud dashboards. So the CREODIAS platform offers data search, data access, and data processing. So we have our huge repository of Earth observation data. We have the catalogs of Earth observation data, and you can access those data within the special protocols like NFS, S3, HTTP, OGC services, and so on. But you can access the data online in the EO Finder and EO Browser, and you can download the data to your computer. So actually there are different paths. So downloading the data or just, working with the data all the time online. Everything is available thanks to the cloud services. So it's processing online, it's access online, and also we provide some software access also online. So here, just a few words, some few sentences about CREODIAS, what you need to know. So as a user of the platform, you have the completely free access to the platform, and you have completely free and immediate access to the Copernicus data and also Copernicus services. We have here the data sets from the Sentinel satellite missions, from the Landsat satellite, Envisat, SMOS, MODIS, and also other data sets. And you can download the data locally, so to your computer, completely for free. But if you choose another path, so working in the cloud, so processing the data in the cloud, then you can launch the virtual machine, and then you have to actually pay for it. So you pay here for the cloud computing and storage in the cloud in CREODIAS platform. So here you can make a use of our virtual machines hourly, or you can also use it as a fixed term. So I would say it differs, because, for example, if you know that you have only some data sets which you need to process and it will just take 2 hours, then it's much more easy just to purchase the virtual machine for hours, for days. But if you will be working on some project for ESA or just your local, let's say, theme, then it will be easier to purchase, to buy the virtual machine use as a fixed term, so for months or for the whole year. Depends on your work and depends on the time which you will spend on working and processing. On CREODIAS, we also offers processing as a service. So these are the special processors dedicated for Sentinel-1 and for Sentinel-2 datasets. So if you would like to process the data, for example, to process Sentinel-1 data and to get coherence information, and then some other information from Sentinel-1, then you can pay for it. You can also do it by yourself. But then we have also here the atmospheric correction based on Sentinel-2 dataset. So you can also order that kind of processing on CREODIAS platform. And we also offer on CREODIAS platform very high resolution imagery. So we have imagery from 3 different let's say, satellite distributors, data distributors, and access to those imagery is also paid. But here, from this point, I would like to invite you to test CREODIAS platform. So at the beginning, you will receive from us 150 euro as a free credits. So you can test the platform and see if it's suitable for you. But for all of you who are the participants of the Cassini hackathon, you all will receive the completely free access to the data, completely free access to the platform. So there won't be needs to pay for the platform. So then all of you, you will have a chance to test the platform, and then maybe in future time, you will come back and then do your projects on CREODIAS platform. Okay. So this is the slide. Actually, this is from 2010-20, how CREODIAS looked like in 2020. So in December, we had over 6,000 registered users. Now it's more. Then every day we receive around 2 petabytes of data, of different data sets. And today I have just checked that the total number of locally available Copernicus data sets, it's over 22 petabytes. So our Earth observation repository, it's actually growing and growing every day. So you can imagine how our servers looks like. So it's a really huge power to store the data and then to process the data. So it's really huge technology, as I would say, like back end of CREODIAS. So when I was talking about virtual machines, I would like to highlight here that when you will go the path where you work on CREODIAS as a cloud service, you can launch your virtual machine, and it can have, we say, different flavors. So for example, I can compare it to a funny situation when just normal day situation, I would say, when you enter the ice cream shop, and then you have different flavors of ice creams. So strawberry with sugar, no sugar, vanilla, chocolate. When you enter the CREODIAS platform, you can also choose different virtual machine flavors. So different sizes, different processors, different RAM, different network storage disk. So it also depends what are you doing. So the important information is that all of our virtual machine, they have built-in access to Earth observation data repository. So when you access the virtual machine, you received complete access to Copernicus datasets. And it's easy because you don't need to download it to your virtual machine. You just open the folder with the data, so you can straight away, really immediately get the data from the folder. So here you can see that we have different EO virtual machines. So they differ on cores, RAM, and SS disks. Then we have bigger virtual machines, and then we have also something which is really nice. We have software-ready virtual machines. So maybe some of you have been who have been working with the GIS and with remote sensing. Some of you know ArcGIS software. So it's also available on our platforms. So you can, if you have the access, if only you have access to ArcGIS software, so you have the license for the software, you can access the virtual machine and then enter your license and then use ArcGIS. So this is actually ArcGIS Pro software, which gives you a lot of possibilities to process the data. And here, together with Esri Europe, we have created built-in tools which will help you to access the data in a really quick way. Before joining CloudFerro, I've been working for Esri, So for me, this topic of using ArcGIS is a never-ending story. I can talk and talk about it. But if you are not an ArcGIS user, you can also use SNAP software, which is the European Space Agency software, and you can also use QGIS software, which I would say is also very good software and more popular among GIS and remote sensing users. We provide also dedicated servers, so also different servers, which I would say are more powerful, and they are, for example, equipped with GeForce, and then probably they are for processing really big, huge data sets. And here, a very pleasant topic about available data sets of Sentinel, of Copernicus imagery on CREODIAS. So as I've said at the beginning, we have here, we give you the access to all of these Sentinel datasets. So Sentinel-1, Sentinel-2, Sentinel-3. And the datasets, they are processed on different levels. So the level 1C before the atmospheric correction, level 2A after the atmospheric correction. So we have also the data which were acquired, for example, yesterday, which were acquired today, but we have also the archives of the data sets. So if you would like to compare the data sets, for example, from today and then from 6 months back, you can do it also here online. It's available for you. We have the data sets from Sentinel 5P, and these data sets are really useful for monitoring, for air monitoring, for atmosphere monitoring. So you can check how the situation looks now, if the atmosphere is good enough. And we have the data sets from Landsat satellite. And here, nice information that we have really, really archived data starting from 1984. And then we have Landsat 8 data, which operates still, and you can get the access to the data. We have NVSat data, SMOS data, and something which is the new information, also MORIS data sets. So not included here, but it's also available online now. And also what I said before, you receive here on CREODIAS platform access to all of the Copernicus services. So atmosphere monitoring, emergency land, marine, and others. So those data sets from those services are available online. So when you access your virtual machine, you can get the access to those data sets. So what is more, we also give you access to other data sets, such as digital elevation monitoring, digital elevation model. So digital elevation model helps you to see what are the differences in the height. So you can measure the height of the area, you can compare it, and you can, for example, wrap the image on the digital elevation model. We have the data from satellite JSON-3, which is the altimeter data, and it's kind of precursor of Sentinel-6. So it also measures the level of the sea. And we have also a very nice product, which is called S2GLC. So it's actually Sentinel-2 Global Land Cover. And this data set was provided by Polish Space Research Center. They have worked on it. They prepared thematical classification of the data sets from 2017. And now those data sets are available to everyone, so you can make a good use of it for your projects. Then very high resolution commercial satellites. So those data sets from commercial satellites are paid. So you can look at the data, but if you would like to make use of it, you would have to buy these data sets. So we have data sets from a Chinese satellite, which is Jilin-1. We have the data sets from Kazeosat, provider from Kazakhstan, and also ComSat. When you look at the data resolution, this is quite a big difference between Sentinel satellite and then those very high resolution data satellites. So here we have the resolution measured in centimeters, and Sentinel has the resolution starting from 10, 20, and then at the end 60 meters resolution. But of course, we do different projects, we process different data sets, so it depends on us what resolution we need for our purposes. Okay, then CREODIAS in practice. So what tools do we have? What tools are available from you, and how you can use those tools? So first of all, the platform, CREODIAS portal. This is, let's say, the most useful portal. So when you enter the CREODIAS portal, I would say that very nice, very useful thing would be to register on this platform, so you can make better use of the tools which are available. You can use our EO browser to browse the data, to look for the data sets which you would like to visualize. So here we have available all of the data sets. So you can visualize the data, you can make the different combinations of the bands of those data sets, you can compare the data on EO browser, you can download the data, but only as a JPEG. So not as the full resolution with all of the bands to your computer locally, but only as a, I would say, print screen. But this is also nice to, for example, put it in your presentation. Then we have the EO Finder tool. And EO Finder tool also helps you to search for the data. It can be also from all of the available satellites. You can indicate when the data were acquired, when the data were published, what was the cloud covered of the data. So really detailed parameters of the data sets. And here you download the data locally to your computer, but like the whole package of the data sets. So for example, the whole resolution, so you will receive 10, 20, and 60 meters, and all of the bands of the satellites. We also provide access to Jupyter Notebook. So if only you are prototyping using Python, if only you are scripting, then you can just use the Jupyter Notebook and then use Python to prototype. So it will speed up your work for sure. And then also different path, so cloud dashboard, so launching virtual machines and then working in the cloud. So we see that there are different groups of users. So those who are only using EO browser, EO Finder, and then download data to computers, and then different group which is working online in the cloud, and then accessing the data set and processing it immediately online. So EO browser, EO Finder, I shortly told you about it. So if only you are a registered user on CREODIAS platform, you can here play with those tools, with those applications, and download the data and work on it locally. So Jupyter Notebook, this is a completely free tool, so not a paid one. And here from this tool, from Jupyter Notebook, you can access the Earth observation repository online. So this is also very useful. For example, because if you will write the script, you will save it, and then, for example, share with your colleague, and then your colleague will have the complete path to the data which you were working on. This is kind of maybe new approach for some of you, but maybe some of you are used to do it this way. Okay, shortly we'll come to the end, and then just the inspiring thing, how you can prepare your projects, how you can share your projects, and using Copernicus data sets and using CREODIAS platform. So Sen4CAP. Sen4CAP, this software is available on CREODIAS platform. This is the software dedicated for agricultural monitoring. Sentinel for Common Agricultural Policy. This software is dedicated to processing of Sentinel-1, Sentinel-2, and also Landsat data. So here, working in the software on your virtual machine, you can process the data set and then receive different products, such as cultivated crop type map, grassland moving product, vegetation status indicator, and so on. So if only you know, for example, which indicators will help you to see how the plants are growing, if the plants are green enough, I would say healthy enough, if the plants are watered enough, you can use this. You can use Copernicus dataset, and you can use Send4Cap software to see that kind of information, to receive that kind of information from the dataset. So very, very useful tools. And this software is available. You can use this software, and all of you participants of the hackathon can have access to the software. You only need to ask us so we can install the software to your virtual machines, because not all of our virtual machines has the software built in already. Then S2GLC, that was a project, and now it's a real data set available. So this is the very nice path, starting from the project and then processing the data and then making the data available to everyone completely for free. So all of you also have access to this data set. So if only you would like to see the classified imagery of Sentinel-2, you can see here where are the water bodies, where are trees, and then some cultivated areas. You can access those data sets and then, for example, process the data set and compare it, for example, from 2021, and then compare it with 2017 and see how the region of your interest changed. So I would say that this is very nice topic for the task, maybe for you. Then another project, and this also the S2GLC, that was a Polish project, and also this is another Polish project, Earth Observation STAT project. So this project was also dedicated to agriculture monitoring, basically processing data sets from Sentinel-1, Sentinel-2 to see how the agriculture, what is the agricultural status in Poland. So this project was done by Space Research Center and Institute of Geodesy and Cartography, and dedicated to a Central Statistical Office and the Agency for Restructuring and Modernization of Agriculture. So then our end users, I mean the end users of this project, they could see also differences in the agriculture, comparing year to year, and how the agriculture has differed among those years. Almost at the end of my presentation, I would like to just to give you maybe information. If you would like to get any financing for your project, which will be done on CREODIAS, you can focus on open clouds, research environments, or networks of resources. Those are the projects, those are the programs which offers financing for the cloud computing resources, for Earth observation resources. So if you're planning to do some projects on CREODIAS platform, you can see if your project can be financed by those programs. Okay, so I'm done. So I could tell you more and more about CREODIAS platform, but unfortunately we don't have much time today. So I would say that this is the end of my presentation, and maybe time for questions.
Okay. Hi there. Hi, Klaudia. Hi. Wow. What a bunch of technology and tools available for the hackers in the hackathon. And maybe I've seen there's a couple of questions that came in via the Q&A already, but I have a question myself as well. So You started out in the beginning saying there's all these Copernicus satellites, and do you have data from all of the Copernicus satellites, or are there satellites from which you don't have the data available?
I would say that from all of them, but not yet from the Sentinel-6. Because
not yet, but that's about to come.
Yes, of course. This is the newest one, so we are expecting the data set soon.
So more petabytes of data.
Yes.
And yeah. So, and if I understand, so the hackers in our hackathon, they will have a virtual machine that is hosted in one of your data centers, right?
Yes, I'm sorry, I forgot to mention it. All of the participants of the hackathon, you will have access to virtual machines, to 5 of the virtual machines, so you can play around and you can work on those virtual machines. And the software will be pre-installed. That will be a QGIS. But if you would be interested, for example, in Sen4CAP software, then just let us know, and we will install also Sen4CAP software on the virtual machines. And my colleagues, they are currently working on the instructions for you, how to access the virtual machines, how to configure it, and how to work easily on it. So you will receive that kind of instructions soon from us.
Yeah, so the hackers at the start of the hackathon, they will be able to access this virtual machine, and through this virtual machine have access to this 22 petabytes of EO data that you have in your data centers.
Yes, so to the huge repository of the data sets.
And then with the software installed on a virtual machine, they can access that data and start to play around with it.
Yes, that's right.
All right. Okay. Interesting. So I saw a couple of questions coming in asking what is free and what is paid, because you had that slide where you said, well, we have these data sets for free, but then we also have the paid ones. What will be available for hackers in the hackathon?
Okay. So for the hackers, so for the hackathon, complete let's say set of the Copernicus data sets. So this is for free. A very high resolution data sets, which are the centimeters resolution, are not available for free.
And which resolution is available?
So all of these Sentinel data sets, so 10 meters resolution, 20 meters, and 60 meters resolution. So it's common.
So when we go, let's say, to 1 meter resolution, that is not.
No, but Sentinel is not operating in 1 meter, so just the very high resolution data are, yes. So this is for free, and then also the access to virtual machines. Normally, the access is paid, but for the participants of the hackathon, it's completely for free.
Cool. And you also show that you have also these data sets besides Copernicus, but those will not be available then.
I mean, we have the data sets, for example, digital elevation model, Copernicus services. Those data sets are also available for free.
Yeah. Okay.
So not only not VHR, so very high resolution data sets.
Okay, no VHR, no very high resolution. Okay, that's the thing to keep in mind. But I guess with all the other data, there's also so much possibilities, right? So you talked a bit already about what software will be available on that virtual machine. Will it be, you said QGIS, that's a program to visualize these images of the Earth?
Just visualize and to process it as well.
And so you can, what kind of processing can you do with it?
You can classify the imagery. So as I showed you that S2GLC product, so the classification of different, let's say, regions of the Earth. So you can divide it into water, forest, open land, and so on. So you can do it in QGIS. You can measure the area. You can compare it one-to-one. So it's all available in QGIS.
All right, interesting. And do you happen to know what are the kind of specifications of the virtual machine that will be available to participants?
Okay, I think that for sure this will be OSGeo Live, so that kind of which supports QGIS software. So as I'm aware, some of you will work on Linux machines, some of you will work on Windows machines. So So it depends.
That was also a question in the chat here. Which operating system will be on the virtual machines?
I think Linux, but I think that my colleagues will explain it better because they are launching the machines, so they know better.
Okay. And so participants will get a full brief once they're registered for the hackathon on you know, what kind of hardware will be available for them in your data centers.
Yes, that's right. But I think that we have asked the question, so probably it will be divided into Windows, Linux, because for example, I'm working on Windows, so I'm working on virtual machine with Windows. I'm not touching Linux, but yeah.
Yeah, all right. And so then I've also seen that so there's either you work directly on the virtual machine or you go via the platform, the EO browser and the EO Finder. And then you also said there's also a Jupyter notebook available.
Yes, it is.
Yeah. And so what exactly is this? How does this work?
So I think that this is kind of notebook for prototyping in Python.
All right.
So that kind of a place window where you can write your scripts in Python, save it, and use it for processing the data. But this is really useful because you got also access to Earth observation data from the Jupyter notebook.
All right, so it's actually sort of scripting environment to write your Python scripts, and then you can directly access the data in your data centers from your script.
Exactly. Yes, this is
right. Okay. Yes. Interesting. And so there's a few other questions I see there in the Q&A. Does Sentinel-2 cover the whole of Europe?
Yes. But some of the data are available online and some of the data are orderable, I would say. That, for example, now I wouldn't answer which are available online immediately and which are orderable, but I would say that most of the Europe is covered.
Yeah, so in your archives you can find information from the whole of Europe.
That's right, yes.
Right. Okay. Interesting. There's also a few questions about whether there'll be further training on how to then start using the platform and so forth. But I believe so. I'll make a bit of publicity here because there's colleagues from Klaudia coming tomorrow as well in our Big Ideas campaign with another session on how to get started as well with the data on the CREODIAS platform. And there'll be also colleagues from CloudFerro who will be available during the hackathon to help with any practical issues accessing the virtual machines and accessing the data, etc. To help you getting started. So don't be afraid, we will support you to start working with the data.
Maybe. Yes.
Yeah, you wanted to add on, Klaudia?
Yes,
sure.
I wanted to just add one more thing, because if you are very interested and if you would like to learn how to use the platform, please just go to our YouTube channel, a CloudFerro channel, because we are publishing there some tutorials, and I even prepared one tutorial how to download the data and how to process them in QGIS. So maybe this will be very useful for the beginning for you if you are not you know, a pro user.
Yeah,
so YouTube,
maybe we can even share a little link in our Discord so that people can find their way there.
Of course.
And then I had one last question. So like the Sentinel cap it's really like an algorithm to analyze Sentinel data, and as I understand it, it's very useful, especially if you're looking to detect greenery and detect plants and vegetation index, etc. So this is some piece of software that the hackers can really use without coding everything themselves, right?
Yes, that's right. And Sen4Cap was initially a project, so it's an open source software. It was developed by a University of Leuven, I think, So scientists and has developed the software, and they made available the software to our customers and our users. So green spaces, green areas, monitoring status of the plants, checking if they are healthy, and so on.
Yeah, all right, interesting. So that I think is a good basis for the hackers to start looking for solutions to digitize our green spaces in the upcoming hackathon. So we're at the end of our session here, Klaudia. Thank you so very much for introducing us to what Copernicus is, to the CREODIAS platform as well, and thank you very much. And I hope our hackers will have learned a few new things about what's already available for them in the hackathon. Okay, thank you very much and see you tomorrow.
Thank you very much. Bye-bye.